Yeah.
All right. Good afternoon or good morning, ladies and gentlemen. How we doing today? Weekend go all right, Ben? Weekend? 2 thumbs up. Zoe? Just 1 thumb up. 2 thumbs up. There we go. Kai? 2 thumbs.
Oh yeah?
Yeah? Tell me more. After class, maybe? Tell me more. Okay. All right.
Actually, I didn't.
You did have a horrible Saturday, but Sunday was so awesome that you still got 2 thumbs up. Close that door behind you, Kane. We're doing thumb checks for the weekend. How was our weekend? It's Tuesday. But did you have a class with me yesterday? So we have our weekend conversation on Tuesday. Well, if you were here on time when class started, Kane, then maybe you would be on top of it. Jeez. I do. All right. So when we left off on Friday, Kane, we had learned the first of 3 Pythagorean trig identities. We learned how to derive it. We learned the synthesis of it, right? And we learned that sine squared plus cosine squared of theta equals 1. Okay? But if you remember, there are 2 other Pythagorean identities. I don't know if I said that. There are actually 3 total Pythagorean identities. Okay? So, to find the other 2 Pythagorean identities, I just divide the first equation, sine squared plus cosine squared equals 1. I divide it by sine squared. Or, dividing is like multiplying by the reciprocal. There we go. So I'm multiplying by 1 over sine squared theta on both sides of my equation. Yes, I can do that, right? So when I do that, what procedure do I have to do? What do we call this process? Distribute. We use the distributive property. So then when I do, I get sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. Now, this looks like a hot mess, right? All right, so let's simplify. What's another name for this fraction? 1. There you go. What's another name for this fraction? Cotangent. Good, though. I like where you're thinking. Not just cotangent, but...
Cotangent theta.
Not just cotangent theta, but cotangent squared theta. That's right. It's squared. Okay, so this is plus cotangent squared theta equals, and what's another name for this fraction?
That would be
Cosecant squared theta. That is your second trig identity, or your second Pythagorean trig identity. So let's write that one down. 1 plus cotangent squared theta equals cosecant squared theta. Okay? And then, how do you think I get the last one? I multiplied this by 1 over sine squared theta to simplify this to 1. How do you think I can simplify that to 1? Oh, 1 over cosine squared theta. Look at that. Kaylee is on top of it. So I multiply both sides of my equation by 1 over cosine squared theta. And then, when I do, I distribute, and I get sine squared theta over cosine squared theta. What's another word for this fraction? not just tangent theta, but tangent squared theta. Tangent squared theta. What's another name for cosine squared theta divided by cosine squared theta? 1. So plus 1 equals, and this one, secant squared theta. Okay? That is my third Pythagorean trig identity. I'm going to write that down right here. Okay, so those are your fundamental trig identities. And you might ask me, so what? So what? Well, some of these trig identities are fundamental, meaning, what does that mean? That means we've proven them, and they are basic to everything that we do in trig, okay? However, sometimes we're presented with an equation, we're not sure if it's an identity or not, okay? If it's an identity, what does it mean? What does it mean if it's an identity? Who remembers that definition? It's true for all values of theta. I could put 0 in for theta. This equation is true. I could put it in theta as pi over 2. This equation would be true. I could put 3 pi over 4, and this equation would be true. It does not matter. If it's not an identity, then that implies that there might be a single or several solutions for theta, but not every solution, right? Or not all possible real numbers. So sometimes what we have to do is we have to verify if something is a trig identity or not. Okay? Plus, it's really good practice for algebra. So we're going to do this one. We're going to verify that this guy is a trig identity. Okay? We must be mindful before we start that there are many ways that this can be proven to be an identity. Okay? I am choosing one way, but when we prove it, I either want to make the right side look like the left side, or I want to make the left side look like the right side. What I don't want to do is I don't want to play with both of them. Okay? So, do you think it would be easier, Kai, if I made the left side look like cosecant theta? Or do you think it would be easier to make cosecant theta look like the left side? You think it'd be easier to make the cosecant more complicated? The other way around? See, it's usually easier to simplify, isn't it? So let's do that. Let's do that. And so, that's the note I make here. When making this call, it's usually easier to make the more complicated side look simpler. So let's get started. Now, I got two fractions that I'm adding together, right? How do I add fractions? What do I need to do before I can add fractions? Common denominator, very good. So, there are two ways I could do this. One is the brute force method, which is what we're going to do first, and then we're going to do a more elegant method. So, brute force. What's my common denominator going to be? Here's what my denominator is going to be. Like if I had 1/2 plus 1/3, what's my common denominator going to be? It's going to be 6, right? It's easy to see because I can't make a 3 into 2. I can't make 2 into 3. So I just smash them together, right? Mash banana, and make it 6. I multiply the two together. I'm going to do the same thing here. I'm going to multiply both denominators together to give me a common denominator. So what am I going to multiply this fraction by? What am I going to multiply this fraction on the left by? Sine over sine. Let's be careful. When we say sine over sine, sine's not a number, is it? Sine is a function that works on a variable. So thank you, Dawson. Sine theta over sine theta. Okay? And then, what am I going to multiply? What am I going to multiply this guy by in order to get a common denominator? Yeah. Yeah, 1 plus cosine theta over 1 plus cosine theta. Oops, I don't want it. I want blue. Calligraphy pen blue. 1 plus cosine theta over 1 plus cosine theta. And that equals cosecant theta. So when I do that, when I do all this stuff, what do I get? What's my fraction on the left turn into? Sine squared theta is the numerator, right? And then the denominator, I'm going to leave it factored. Okay? And the reason I'm going to leave it factored, I don't want to multiply them together unless I have to. Not sine times, but sine of theta times, right? Remember, sine is a function, so it needs something to work on. So just like that, right? How about the one on the left? Let's do that one in green. Distribute, right? Boom, boom. So I'm going to get cosine theta. I'm going to multiply this one through. Plus cosine squared theta. And that's all over. Again, leave the denominator factored. Sine theta times 1 plus cosine theta. And this all equals cosecant theta. Or does it? Now, here's what I can do. I can mash that all into one fraction, can't I, Logan? I don't need to have two different fractions. I can mash it all into one. So that's what I'm going to do next. I'll put this in black again. I got sine squared theta plus cosine theta plus cosine squared theta all over sine theta times 1 plus cosine theta equals not cosine, equals cosecant theta. What can I do to make sense out of this? What do you think I can do, Riley? People say math isn't creative. This is where you get creative. Does that help? No, not really. Let me try this. Addition's commutative, right? What does it mean to be commutative, Kai? What does it mean when I say addition is commutative? No, addition. Is 2 plus 3 the same as 3 plus 2? Yeah, order doesn't matter, right? We call that the commutative property. Does it matter if I have sine squared plus theta plus cosine theta plus cosine squared theta? Or can I jumble the order of that? I can jumble the order of that. So I'm going to do that. I'm going to do sine squared theta plus cosine squared theta plus cosine theta all over sine theta times 1 plus cosine theta equals cosecant theta. What do you think now, Riley? Look left. See if you see anything in there that you also see on the left-hand side, to the left of the whiteboard.
Yeah, I do, but oh wait, oh you could, yeah. Cross out sign. Can you do that or no?
Cross out sign.
Yeah.
So when I say look left, and your eyes are glued to this spot,
Yes.
you know what that tells me? It tells me you're not looking left.
No, I looked left.
So what did you see over on the left-hand side?
Sign. Oh, you meant like
Yeah, I meant to the left of the whiteboard. Look over there to my fundamental identities.
Cosine squared theta plus sine squared theta.
Oh yeah.
Yeah,
One.
this guy right here
Equals 1.
is one of our identities, and it equals 1. So now I got 1 plus cosine theta all over sine theta times 1 plus cosine theta equals cosecant theta. And we're almost done. We are almost done. What can I do now?
And it's only 1 plus cosine theta.
Yeah, because this is a factor, right? This guy's a factor, and this guy's a factor.
Sine theta. Also, this is going to be sine.
So what does that leave me on the numerator? What does that leave me on the numerator, Logan?
1.
1. Ah. Magic, right? So this is going to be 1 over
I like to prove for
sine theta equals cosecant theta. Is that a truism? Yes. How do we know?
It's identity.
It is an identity. So now I can say cosecant theta equals cosecant theta Q E D. Yes.
What does that mean?
Quad erat demonstratum, Latin. From this I get that. Actually, the literal definition is from which it has been demonstrated.
Why do you remember?
So I took 2 years of Latin in college.
Ooh.
Is there a reason?
Actually, 2 semesters, because I wanted to be a lawyer for a while. For about a year. And then I realized you got to do a lot of reading in history. I was going, well, that wasn't clear. I wanted to be a lawyer, and you don't get to be a lawyer in undergraduate school. You get to be a lawyer in grad school, right? So before you go to grad school, you have to have an undergraduate major, and my major was going to be history. And then I realized, well, in history you do a lot of reading, and I like reading. But I don't like reading text, right? I like reading like novels. And every time I tried reading a history book, I get attacked by the Sandman. And I'd start to go to sleep. And so it didn't work for me. So here's what we're going to do. That was the brute force method, right?
Yeah.
We were doing stuff that we knew how to do already, and we got to our answer, right? Right, Zoe? Now we're going to try something a little bit more elegant. Okay? So sine theta over 1 plus cosine theta plus cosine over sine, cosine theta over sine theta equals cosecant theta. Okay? We're going to try a little bit different strategy here, all with the purpose of showing you that there's more than one way to skin a cat. Okay? Really? And now your reply to that's going to be only a hillbilly wants to know the different ways with which to skin cats.
I'm not good with that. I want to skin my cat.
All right, so, yeah, I do too. All right, so here's what I'm going to do. Instead of making my denominators the same in the first step, I'm going to make my denominators the same in 2 steps. the first step I'm going to do is I'm going to multiply this side by 1 minus cosine theta over 1 minus cosine theta. You might be asking yourself, Mr. Coach, why in the heck would you do that? And I will show you in a second. So my numerator becomes sine theta minus cosine theta sine theta. What's my denominator become? How do I do that? It would be 1? Or 1 and then you're formulating the rest of it? I got 2 things times 2 things, right? So what do I have to do? I got to distribute between both terms, right? I have FOIL that thing, right? So 1 times 1 is 1. 1 times positive cosine of theta equals positive cosine theta. 1 times negative cosine theta equals, those go away, right? And then negative cosine theta times positive cosine theta gets me negative cosine squared theta. Okay, now, so what? Let's go back to cosine squared theta plus sine squared theta equals 1. And let's subtract cosine squared theta from both sides. So, here's what I did. I took this Pythagorean identity that I got right here, right? Cosine squared theta plus sine squared theta equals 1. And I moved my cosine over by subtracting cosine squared from both sides, right? And what do I got? I got sine squared theta equals 1 minus cosine squared theta, which looks an awful lot like my denominator in the top, right? Okay, so substitution property of equality. Very good, Dawson. I'm going to replace this guy with that guy because that guy is equal to that guy. Okay? So this is going to be sine squared theta. Now, you know what I shouldn't have done? I shouldn't have distributed this times this, should I have? I shouldn't have done it. I should have just left it 1 minus cosine theta times sine theta. Why do I say that? Ooh. Let me do that. Let me do that. So I'm going to leave this the way it should have been left. Can I simplify that fraction? What can I eliminate, Ben? This sign? No, 1 minus cosine squared theta equals sine squared theta. But I can't do that, right? But I got this sine theta, right? And that cancels out with what, Zoe? How many things is this multiplied together? It's sine theta times sine theta, right? So that cancels out with the one on top. And so I get over sine theta, right? So now I'm going to write this over here. 1 minus cosine theta over sine theta plus cosine theta over sine theta equals cosecant theta. Can I push that all into one fraction now? I got common denominators now, don't I? So now I got 1 minus cosine theta plus cosine theta over sine theta equals cosecant theta. What happens to my cosecant, or my cosines there, Logan? Stay with me, Logan.
Take out the cosines.
Those go bye-bye, right? Minus 1 and plus 1 gets rid of them, and I'm left with 1 over sine theta equals cosecant theta. More than one way to skin that cat, right? Either way is, both ways are equally valid. I call this one more elegant because did I need to manipulate this fraction to find a common denominator? No. So I call it more elegant, but that doesn't mean more valid. I am equally happy if you do this one as I would if you did the strategy on the other page. Okay? Now, let's verify that this expression is a trig identity. I haven't done this one. I haven't done this one. So this is going to be fun. Let's do this together. I don't know yet. I don't know. But after this, we're going to simplify a trig expression. And then we're going to simplify a trig expression. And then it's the practice set. Okay? So we're nearing the end of our lesson today. But I haven't done this one yet. So now, how in the heck do I do this? I'll tell you what I'm going to do. Am I going to do that? Okay, here's what I'm going to do. Whenever I am lost, I turn everything into sines and cosines. What do I mean by that? Yep. So secant is what? Very good. So secant is 1 over cosine theta times, we'll go write sine theta as a fraction. It would be what? Sine over 1, right? Sine theta over 1. Does everybody buy that? Okay. And then on the bottom, I'm going to rewrite tangent and cotangent as... I'm going to use my quotient identities. Yeah, sine theta over cosine theta. Plus, cotangent is cosine theta over sine theta. And this all equals sine squared theta, supposedly. Okay? Now, I can do some mathy math, right? So, 1 over cosine theta times sine theta over 1. That equals sine theta over cosine theta, right? And we got a name for that, don't we? Tangent theta. So numerator is just going to be tangent theta. Should I leave it as sine theta over cosine theta, though? Let's leave it as sine theta over cosine theta. And I say that because I'm suspecting, because I want to change this into sine squared theta eventually, that I'm going to want it to be in this form. So you can change it to tangent now if you want to, but we may just have to change it back in the future. Is everybody clear on that? All right, so this is the numerator, right? The denominator, let's do in blue. We got to find a common denominator again, right? What do I multiply this first fraction by to give me a common denominator? What is going to be my common denominator anyhow, Logan? Not quite. Remember when it was 1/2 plus 1/3, what was my common denominator?
6.
6. I just multiplied the two together, right? Multiply my denominators together. I'm going to do the same thing. I'm going to do cosine theta times sine theta, which means I got to multiply this guy by what? Sine theta over sine theta. So sine theta over sine theta. And that's what I'm multiplying that by. What do I got to multiply this guy by? Cosine theta over cosine theta, right? And what's that going to get me? It's going to give me a denominator of sine theta cosine theta, right? What is this term going to be? Sine squared. What's this term going to be? Sine squared plus cosine squared. What's that?
1.
Equals sine squared theta. That's just that right there. Okay? Now, I got fraction divided by a fraction. How do I do that? Multiply by the reciprocal. So, I take sine theta over cosine theta, and I multiply it by the reciprocal of 1 over sine theta cosine theta. Yes? What happens?
Sine squared theta plus cosine theta over cosine.
Is it sine squared theta plus cosine theta?
Oh,
No, because it's all multiplied, right? But before I multiply them, can I reduce? Can I reduce before I multiply? What can I get rid of? Cosine thetas. Let's do that in green. So this goes away, and that goes away. And now, what do I got? Sine squared theta. So then, voila. Did I have an idea that I would be able to, did I know my path before I took the first step? If I lied to you, I knew my path before I took the first step, but what did I say? I said I've never done this one before, so I just started with what I knew how to do already, right? And I knew that my first step was, okay, I can't make sense of this. I can't see any greater logic behind this, right? I don't have that magic key. So let me just do something that I know how to do. So I applied my reciprocal identities and my quotient identities. And that got me started. Do we see how we can use all these together just to take the first step, right? Too often we look at something and we don't know what to do because it seems like too big a problem, right? Take the first step. Do what you know to do. Heck, you're given these. Apply them. See if it gets you any extra wisdom towards the next step. Okay? We can also use these things to simplify trig expressions. Okay? We can use these to simplify trig expressions. How can I simplify this one? Do you see anything on the whiteboard to the left that might help me with this guy? What do you think, Dawson? Tangent squared plus 1 equals secant squared theta. Okay, so that would be tangent squared theta plus 1 over. Is that what you want me to do? Or do you want me to replace this secant squared theta with tangent squared theta plus 1? Okay. Both of them? Oh. So this became this. And this became that. Okay, this might help. So I can simplify the denominator though, can't I? What does that become? Tangent squared theta, right? The ones cancel out. You see that, Kai? So then this becomes, now I'm going to write it down here, tangent squared theta plus 1 over tangent squared theta.
Am I done?
Guide your attention back to this. I find these to be eminently helpful. Quotient identities, to me, are some of the most helpful. So what should I do? How about this? Screw the quotient identities. Can I do this? Can I do that? I'm just splitting those into two separate fractions, right? I can do that. Why couldn't I do it up here? Why couldn't I split this into secant squared theta over secant squared theta minus secant squared theta over 1? Why couldn't I do that? Do fractions work that way?
No.
Or I can just split them up based on the denominator? No, I can split them up based on the numerator, right? But I can't split them up because the denominators need to be the same. Okay, so simplify this guy. This here is 1, right? So this is 1 plus, and what is this guy? This is going to be a reciprocal identity. I heard it. Cotangent squared theta. Okay. Now, look back to your identities. Cosecant squared theta. There we go. So this simplifies to cosecant squared theta. So what you're going to find, you're going to ask yourself, how do I? No, you're not going to ask. You're going to ask yourself how. But when you get frustrated, you're going to more accurately ask why. Why do I need to do this? And trick of it is when you're modeling a relationship in the world, in your job, in your career, whatever, and you're working with trig functions, you're going to get stuff that looks like hot garbage, right? And the goal, so that you don't have to try and figure out the relationship by looking at all this hot garbage, is to try and simplify it as much as possible, so that we can make sense of the relationship better. Does that make sense? As far as the why? Now, we're going to try something a bit harder. Great. Great. Let's try something a bit harder. Okay? So now, we're going to do this one. This one's fun. This one's fun. So, let's square these two guys. I got this squared plus this squared, right? let's square both of them so that we got apples and apples, right? So to square them, I would do 4 cosine theta minus 3 sine theta times 4 cosine theta minus 3 sine theta. That's the first part, right? I got a big plus sign, and then 3 cosine theta plus 4 sine theta times 3 cosine theta plus 4 sine theta. I'm going to do this one in red. I'm going to do this one in green. So, how do I do the red one? What's going to be my first term when I distribute the term that's underlined in red? What's going to be my first term? 16 cosine squared theta. So this is 16 cosine squared theta. That's that right there, right? 4 times 4 is 16. Cosine times cosine is cosine squared. Okay? Now, I want to do outer. So I'm doing that. Plus or minus? Minus. So minus 12. Minus 12 what? Cosine theta, sine theta. Okay? And then now I want to do this one, right? So that's another minus 12 cosine theta sine theta, right? So can I just change this 12 to a 24? Let's do that because I'm dangerously close to running out of room. So minus 24 cosine theta sine theta. And then I want to do that guy, right? Plus 9 sine squared theta. Okay, so now I got, get rid of that. Now that's the red, right? Now we got the green to do. So let's get in our green and do our F in FOIL. Now I got what? So, and that's going to be a plus, right? Plus 9 cosine squared theta. Okay. And then what? I want to do the outers again. I want to do plus 12 cosine theta sine theta plus 12 cosine theta sine theta. And then I want to do the inners. Yeah, so just change that to 24, right? What do I need to make sure of before I can just say that's 24? I need to make sure I'm getting sine, cosine, right? Okay. And then I'm doing the last, right? Plus 16 sine squared theta. Now, I'm going to match those two together. Actually, let me do that in a different color. I'm going to do, no, I don't want that either. Let's do that color. I'm going to do those two together. And I'm going to do these two together. So these are all This is all commutative property stuff, right? I can jumble the order, right? As long as I keep track of that guy, right? I have to be mindful that I'm minusing that 24 cosine theta sine theta right there, right? But other than that, I can jumble the order all I want, right, Kai? So then I get, and I'll keep the colors just to make sure that we're 16 cosine squared theta plus 16 sine squared theta minus 24 cosine theta sine theta plus 24 cosine theta sine theta plus 9 sine squared theta plus 9 cosine squared theta. See where this is going, Kaylee? Who sees where this is going? So now I can associate. Well, I'm going to associate these two guys. I'm going to make this plus a negative so that I can associate those two guys. And I'm going to associate those two guys. Remember, associative property means I can do this by itself, this by itself, and that by itself, and then add the results of all those together, right? But before I do, what can I factor out of this set of parentheses? 16, right? So this first one right here is 16 times cosine squared theta plus sine squared theta, right? You with me, Riley?
Yep.
What about the middle what about the parenthesis over here? Those guys go bye-bye, right? So I'm going to ignore that. That will just put a big blue and say 0, right? What about the bottom one, Ben? What can I factor out of the bottom one? 9. So this is going to be plus 9. I don't want to do that in black. Plus 9 times cosine squared theta plus sine. Man alive. Plus sine squared theta. This is a fancy way of writing what number? And this is a fancy way of writing what number? So then this is just 16 plus 9, which equals 25. Now, if I was presented with this, would I much rather work with that when I'm doing algebra? You bet your hind quarters, right? That should give you all that you need for the practice set. Now, we are going to work tomorrow on, tomorrow's going to be work day.